Principle 3 that has to do with the fact that the ocean is a major influence on weather and climate. And let's discriminate what is the difference between weather and climate. Weather is happening right now or in the very near future. Temperature and pressure of the air, the clouds, the winds, precipitation, which is actually the rainfall, are all elements that are referred to the weather broadcast. The climate is where we live, the regional climate is the average weather in a place over more than 30 years. Weather can change rapidly, while climate changes slowly over decades or more. And global, and global climate depends on the amount of energy received by the sun and the amount of energy that is trapped in the system of the Earth. And as also Francesca mentioned before, we have roughly 5 parts of the system of the Earth, which is the atmosphere. In the lowest part of the atmosphere is weather is happening. We have the biosphere, all the living things, the geosphere, including minerals and rocks and the soils, the cryosphere, which is the frozen part, and of course, the hydrosphere. The ocean is covering more than 70% of the surface of the Earth. You have heard that before, and it is also comprises 97% of the water on our planet. The ocean absorbs most of the solar radiation reaching Earth, as it covers more than 7% of the surface, and it has a large capacity, heat capacity. That's why the ocean warms and cools more slowly than the atmosphere. That means that the weather along the coastlines tend to be calmer, milder than the weather in inland regions. So along the coastlines close to the ocean, we have fewer hot and cold extremes. And of course, you will realize that there are a lot of topics that are connected through the principles and the concepts. You can see now the water cycle, but what I would like to impose here is that the ocean is the largest water reserve in the world. It has continuous changes with the atmosphere, and that's why it's closely related to the climate. Due to global warming, the water cycle tends to accelerate and causes more frequent extreme weather events such as rainfalls and droughts and cyclones. And the ocean doesn't just store solar radiation, it also helps to distribute heat around the globe. And here you can see that the equator receives more sunlight than the poles. In addition, as we said before, the ocean absorbs the majority of radiation from the sun. So in the tropical waters around the equator, the ocean acts like a massive solar panel, retaining heat. But due to Earth system budget, the heat is transferred from the tropical waters to the poles through the ocean. and drives actually atmospheric and ocean or the oceanic circulation. Some words about the atmospheric circulation. The ocean, from the ocean, we have the thermal energy and the water that is evaporated and create winds and rain clouds, and especially around the tropics, we have a lot of radiation reaching, a lot of radiation absorbed, so a lot of rain is created around the tropics. And again, about the ocean circulation that Francesca mentioned before, because actually heat exchange between the ocean and the atmosphere drives also oceanic regulation. Oceanic regulation has to do with the ocean currents that they flow because of the spin of the Earth. They flow clockwise in the northern hemisphere and counter clockwise in the southern hemisphere. We have surface currents created by winds and vertical currents created by differences in density. So these oceanic currents counteract to counteract the uneven distribution of solar radiation reaching Earth's surface. There are events like El Niño, where they, let's say, change this normal oceanic circulation. During El Niño, we have the warming of the southern coast of America. And this event usually happens during Christmas. That's why the Spanish name El Niño, coming from the name of baby Jesus. And actually, it affects seawater temperatures and wind regimes and marine resources, because during normal years, we have an upwelling here that brings to the surface water rich in nutrients, and so the water here is productive. But while we have these events, this upwelling is getting weak, so we have this kind of effect. And again, about the carbon cycle, but what I would like to impose here is that the ocean is a large carbon sink on Earth. The carbon CO2, which is in the atmosphere, is dissolved in the seawater, and through the sea currents goes deeper to the deeper layers of the ocean. And also the phytoplankton that is distributed in the sunlight surface ocean water layers uses the carbon via photosynthesis in order to make organic matter. So in this way, these two both mechanisms, the carbon is concentrated, large amounts of carbon is concentrated in the ocean. CO2 as a greenhouse gas traps heat and making Earth warm and habitable. But since the Industrial Revolution, greenhouse gases have increased, particularly CO2 and methane, due to industrialization, the burning of fossil fuels, and deforestation. So CO2 have increased more than 25% of the normal values, and the global temperature has risen. So we have this global warming, which makes things a lot different than it used to be. And because of this increasing of CO2 concentrations, we have different impacts on the marine species. There are marine species that they adapt to the temperature changes. There are species that they migrate to North Poles or to new areas, and there are species that they disappear, such as corals. And because there is this warming of the temperature, not the warming, okay, yes, the warming of the temperature, we have less, let's say, absorption of CO2 in the seawater. So this is an effect, a change that is a result of the change that is already be done. We also have the ocean acidification, which has to do with increasing CO2 in the ocean. And by increasing CO2 in the ocean, we have more acidic environments, which is not something good for organisms that consist of calcareous skeletons or shells. Some also physical consequences of the increase of atmospheric CO2 are the ice melting and shrinking mountain glaciers. These are causing rising of sea levels. Rising of sea levels is also caused due to excess heat, which is stored and make the volume of the water of the ocean bigger. And as we said before, the water cycle, the acceleration of water cycle makes more intense and frequent hurricanes and rainfalls and droughts. And all this acceleration of water cycle and rising of sea levels cause coastal erosion and flooding, affecting coastal habitats such as mangroves and seagrasses that are potentially also capture CO2. That's why we need to have adaptation and mitigation in order to secure our ecosystems and populations and economic activities. I think that you have all realized that it is really important also to be climate science literate. As I told you before, the concept of ocean literacy turned out to be a successful concept, and it is something that it is extended also to other, let's say, earth sciences.
3 minutes, Yolanda.
Yes, I'm finishing. One of the Sustainable Development Goals, of the 17 Sustainable Development Goals, has to do with climate action. It's the 13th Sustainable Development Goal. And of course, we have the Challenge 5 of United Nations Decade of Ocean Science for Sustainable Development that focuses on ocean-based solutions to climate change. 2 of the 5 EU missions are focusing on climate change and climate neutral cities. Apart from the healthy oceans and seas and coastal and inland waters. And here you can see again an example of the flow diagram and the charts that they have developed for the scope and sequence. of ocean literacy, and you can see some of the topics and subtopics that you can use. You can refer to them to your pupils. Oops, sorry. And of course, some of the projects that have been developed within the framework of EU Blue Schools Network and can inspire also your projects that you want to develop in your classrooms.